The stock buy and sell problem asks us to find the maximum possible profit we can earn by buying and selling a stock multiple times over consecutive days. While we can make as many transactions as we like, there is a catch: we must sell our current stock before we are allowed to buy it again. Let's visualize this using a historical price array of 10, 50, 20, and 60. Our first instinct might be a brute force strategy. Using recursion, we can try every single valid combination of buying on day I and selling on any subsequent day j. Because this structure branches out into an exponential recursion tree of options for every single day, it recalculates the same subproblems repeatedly, making it highly inefficient for larger timelines. To optimize, look at the price graph's geometric behavior. We can track local valleys, where prices stop dropping, and local peaks, where prices stop climbing. Locking in transactions purely between consecutive valleys and peaks guarantees optimal returns. For instance, we see a valley at 10 and buy. We hold until the local maximum peak hits 50 and sell. This net transaction nets us a clean 40-unit profit. Next, the price drops back down to a new local valley of 20. We buy again and ride the upward trend all the way up to the next local maximum peak of 60, collecting another 40 units of profit. While the peak valley method works in linear time, finding actual mathematical peaks and valleys requires complex look-ahead conditional logic. We can simplify this entirely using a brilliant mathematical property: accumulating immediate crawling gains. Think about it this way: buying at 10 and selling at 50 yields 40. But that is mathematically identical to buying at 10, selling at an intermediate point, buying back instantly, and selling at 50. Therefore, if we simply grab every single positive price jump between adjacent days, the total summation perfectly aggregates into the absolute peak valley maximum profit. This means we don't need to look ahead or hunt for peaks. We just scan from left to right once. Let's map this seamless crawling logic directly onto Python code. We start our loop at index 1, looking at a price of 50, and compare it to yesterday's price of 10. Since 50 is greater than 10, we have an upward segment. We calculate the difference of 40, and instantly add it to our running profit tally. Moving to index 2, today's price dropped to 20. Comparing it to yesterday's price of 50, the condition fails because 20 is less than 50. No profit is recorded, and the script moves cleanly along. Finally, at index 3, the price climbs to 60. Compared to yesterday's value of 20, we encounter another positive growth trend. We extract the 40 units of difference, adding it to our account to hit a grand total profit of 80. To wrap up, brute force recursion explores all paths in exponential runtime. Tracking explicit valleys and peaks streamlines this down to efficient linear time. But by simply accumulation adjacent positive price deltas, we achieve that very same linear efficiency with far more elegant, robust, and maintainable logic.